Hey guys, welcome back to my YouTube account. This video is the third installment of my Year 10 revision questions, and we're starting off from question number 22 right now. And all we need to do is write the formula or the chemical formulas of the following compounds. The first part is potassium chloride. So the information that's needed from this is the charges located on the periodic table. The way I remember it is this is group 1, group 2, and etc, etc. I start off by group 1 is always +1, then +2. We miss out all of the transition metals, and we go +3. We have a break, and then we start from 3 minus, 2 minus, 1 minus in these groups, and then the normal gases have no charges. In other words, they follow the octet rule. So the first question is potassium iodide. What I'm going to do is I'm going to write down the chemical formula. So potassium is right there, which is K, and because it is in this group, it has a charge of plus 1. Plus 1 is the same as plus without any number, plus Cl chlorine, which is on this side. Chlorine is on here, and the charge is 1 minus. I'm just going to put a minus there. And now I need to come together. They need to come together to form a new product here. So potassium plus Cl minus, these are the same numbers, so they cancel each other out. It becomes KCl. Okay, that is the answer for the first part. The second one is magnesium iodide. So magnesium, we need to look for magnesium on the periodic table. Magnesium is here. This is the 12th element. Has an atomic number of 12, but the most important thing is we need to know the charge. So it's Mg 2 plus, this is iodide, so magnesium iodide. I need to look for iodine. Iodine on the periodic table is right here. So this is a charge of I minus, because iodine is right there, so this is the group there, in the charge there. Now because the numbers are different, this needs to happen where they just need to exchange numbers. This is the easiest way to do it. So this number here goes here, and this number here goes there. So because the 1 goes next to the Mg, it just stays as Mg. I, and the 2 went there, so therefore it goes I2. And that is how you do the magnesium iodide question. The third one is magnesium sulfide. So we've already done magnesium, so magnesium is 2 plus sulfide or sulfur. I need to look for this. Sulfur is on the periodic table, so sulfur is here. It's got a charge of 2 minus, S2 minus. So as previously mentioned, these have the same numbers, therefore they cancel each other out, and it goes to MgS. And the last one, you have aluminium sulfide as well. Let's do that one quickly. And the last one is probably going to be the same answer as that one. So it's going to be aluminium. Aluminium is located here. Aluminium 3 plus sulfide. Sulfide, we've already found sulfur, so it's S2 minus. What is going to happen is this number is going there, this number is going there. It's going to be Al2S3. And the last one there is magnesium 2 plus, we've already found it, plus oxygen, which is O2 minus. Cancel each other out because it's the same number, and it's MgO. And that is the answer of question number 22. Okay, so now back to question 23, and the question is complete the word equation for hydrochloric acid plus potassium hydroxide, and then it's asking us to write a balanced symbol equation. So when looking at this, I need to look at the reaction. What type of reaction is occurring? I wouldn't know what to write on the sides if I didn't know what type of reaction it was. So what I mean by that was it an acid metal reaction, an acid base reaction, an acid carbonate reaction? You may need to revisit these terms back in your notes. So what I'm going to do is look, so hydrochloric acid, look there, and I've got a potassium hydroxide. I have noticed that I have an acid and also have a hydroxide here, which is, it's an acid-base reaction. So I've diagnosed that this reaction is an acid, base, or a neutralization reaction, meaning acid plus base equals salt plus water. And I don't mean a salt as in sodium chloride, the salt that we eat in our foods every day. A salt means anything that replaces the hydrogen in the hydrochloric acid, or the acid. So hydrochloric acid, I'm just going to make it easier. I'm just going to write down the chemical equation. HCl plus potassium hydroxide. I know hydroxides, going back to the polyatomic ions table, are OH minus, and K is K plus. So K plus plus OH minus. This is called the ionic equation. This gives me K. Oops, sorry about that. KOH, or potassium hydroxide. So plus KOH. So what I need now is a salt, and I need water. So there's guaranteed water in every acid-base reaction. In other words, there's always going to be H2O. But I need a salt. So what's going to happen is anything that replaces the place of the hydrogen is going to give me the salt. So KCl is the salt, and therefore I have to put the remaining part, which is the water, H2O. And this is the chemical symbol equation for this. How do I write this on the paper? So this is hydrochloric acid plus potassium hydroxide plus sodium hydroxide. So I've got the potassium taking the place of the hydrogen. Now I've got KCl, or this is potassium chloride. Plus water. Okay, so now the last part is, now that I have these symbols here and I've got the chemical equations, I need to balance the equations. So what I'm going to do is I'm going to, as if you refer back to my other video, we just need to balance it. So I've got the H here, I've got the Cl there, I've got the K, and then I've got the oxygen. And I've got the same ones on this side, Cl, K, and oxygen. And let me count how many hydrogens there are there. There's one there. Chlorine, there's one chlorine. Oh, sorry, there are two hydrogens because there's one there and one there. So that's two there. There's one K and one oxygen. On this side, however, there are two here. There is one Cl, there is one K, and there is one oxygen. So therefore, it's already balanced, and this is a balanced chemical equation, and that concludes the video for today.